Hey guys, in this video series, we're going to be looking at a bunch of fake proofs and what the actual problems are behind them. So in this video specifically, we'll be talking about horses and cats. So the first thing we're going to prove is that all horses are the same color. And in order to prove this, we're going to use induction, and we're going to do induction on the size of the group of horses. So if we show that every finite group of horses has the same color, then all horses have to have the same color. So the base case, n equals 1. Well, a horse has the same color as itself, so this confirms the base case. Now let's look at the inductive step, n equals k plus 1. So we assume it already holds for n equals k, and then we try to show that it holds for n equals k plus 1. Well, assuming that it holds for n equals k, we can notice that the first k horses will have the same color because that's the inductive hypothesis. And then the last k horses in this group of size k plus 1 also have the same color by the inductive hypothesis. So putting this together, that means the first horse and the last horse have to have the same color by transitivity, because the first horse has the same color as these two horses and the last horse has the same color as these two horses. So by transitivity, the first and the last horse have to have the same color. And so therefore, all horses in this group of size k plus 1 have the same color. And this is essentially the proof. So here it is written out as a nice theorem. Any group of horses is the same color. Base case, a horse is the same color as itself. Inductive hypothesis, suppose it holds for every group of size n equals k. Now for n equals k plus 1, here's how you would prove it formally, and I mean that in quotes. So by the inductive hypothesis, the first k horses are all the same color, and we need to check that the last horse is the same color as the first k. So we know that the horses from 2 to k plus 1, aka the last k horses, are the same color. And so by transitivity, horses 1 and k plus 1 are the same color. So we're done. Now what's the problem with this proof? I'll give you a couple seconds to think about it. Okay, so for those of you who figured it out, good job. The idea is that you assume here, when you're using this transitivity, that there even are horses to compare. So for example, going way back to our pictures, we're noticing that the first 3 horses have the same color in this example, and the last 3 horses have the same color. So our transitivity was comparing this horse, which had the same color as these horses, which had the same color as this last horse. But if these 2 horses don't exist, then this argument doesn't hold. In other words, for n equals 2, this argument doesn't hold. So that's the problem with this proof. The other way you could think about it is we actually used a faulty base case, which is that technically our base case should have been n equals 2 instead of n equals 1. That's one way to think about it. I usually don't like to think about it this way just because then it causes confusion as to what you should pick for your base case. So you could say that, oh, this induction argument doesn't work because you picked the wrong base case. And then it's unclear whether you should be picking a base case of n equals 1 or 2. So I like this reasoning better, where you realize that the transitivity, where you try to compare this horse with the color of these 2 horses with the color of this last horse, this breaks down with n equals 2. So it doesn't hold for a general k, and that's the problem with this proof. Okay, now moving on to the next proof with cats. So this is a theorem which says that all cats have 9 tails. Well, it starts out like this. No cat has 8 tails. A cat has 1 more tail than no cat. QED. What's the problem with this proof? There's a very clear logical mistake. If you figure it out, shout out below in the comments. All right, so that's all for this video. If you like this series, hit the like button and subscribe so I can add more videos like this where I have some fake proofs and I break down why they're fake. And that's all for now. So until next time, thanks for watching.